Alright, welcome to the first video for Math 11 Methods 2. I'm going to make these videos using the same Jupyter notebook software that you use for your weekly notebooks and assess questions on CoCalc. So what you see here is going to be very similar to what you see when you log into CoCalc to do those. Now if you don't know what I'm talking about and you don't know what CoCalc is, that means you haven't watched the introductory video for Math 11 yet, so stop watching this one and watch that now. You'll find it at the top of the Moodle page for Math 11. Okay, so having watched that video, you know that we're spending the first 4 weeks of Math 11 learning about Python, which is a programming language. And what Python or any programming language lets you do is to give instructions to the computer to make it do something. For example, you might want to do some kind of mathematical computation. And the simplest example of a computation would be basic arithmetic, which is the subject of this first video. So let's begin with the most basic of all basic arithmetic: addition, subtraction, multiplication, and division. And we do those in Python using the ordinary keyboard symbols for doing this. So let's work out 2 plus 4 minus 9. You can see I've already typed it in this code cell here. So a code cell is one of these things with the word in to the left and then some square brackets. And if I click in there and then press Shift and Enter or Control and Enter, then Python will work out the result and print out the result beneath the cell. So next to out, you can see here it has the result of that computation, which is minus 3. If we want to do multiplication, we do that with an asterisk like this. So 2 star 4 or 2 asterisk 4 will be 2 times 4, which is 8. And finally, we can do division with a forward slash. So if you want to do 1 divided by 3 like this, then you can click in that code cell, type in your division, press Control and Enter or Shift and Enter, and you can see you get at least a decimal approximation to 0.33333. So if you've come to Python from having done some programming before, especially in languages like C and Java, you might be a bit surprised about that answer, because when you do division in C or Java, then you'll always get an integer answer if you divide two integers. In Python, that doesn't happen. So division of integers behaves as we expect in mathematics. When you divide two integers, if one isn't divisible by the other exactly, then you'll get a decimal answer like this. So let's now do our next most complicated bit of arithmetic, which is powers. So what if we want to work out a to the power b in Python? The way to do that is by using 2 asterisks. So if you want to work out 2 to the power 4, then what you need to do is do 2 and then 2 asterisks and then 4. When I run this code cell, you can see we get the answer 16 as we expect. So sometimes when people are typing, they will use this symbol here, the little circumflex or hat or whatever you want to call it, to indicate powers. That does not work in Python. So in our next cell, I've got 2 and then circumflex or hat or carré 4. When I run this, we get the answer 6. That's not 2 to the power 4. So you must use 2 asterisks if you want to compute powers in Python. So just another comment about that code cell. You can see in this code cell where I had 2 and then the carré and then 4, I've got the hash symbol or pound symbol and then some text telling me what's going on in that cell. That is called a comment. And what's happening there is Python ignores everything that comes after a pound sign or hash sign like this. And that's very useful to us because it lets us leave explanations of what a particular line of code does or does not do. So that Python will just ignore it, but you can put it there to remind you or future you when you come back to this notebook exactly what's going on in a particular code cell. So this is very useful to us when we're doing complicated or unexpected bits of code. It lets us remind ourselves what a particular line of Python code does. Okay, so what if we want to work out something like a square root or a cubed root? Well, of course, that's another instance of exponentiation. So if you want the square root of a number a, that's the same as a to the power 1/2. So if we want to work out 2 to the power 1/2, for example, if we want the square root of 2, we can do that just by doing 2 and then our exponentiation symbol, 2 asterisks, and then 0.5. So when I run this code cell here, you can see I really do get the square root of 2. So what about if I want the cube root of 2? Well, of course, that's 2 to the power 1/3. But if I want to type in 1 divided by 3 instead of 0.333333333, then I need to use brackets to tell Python to do the division first. So here I've got 2 to the power of, in brackets, 1 divided by 3, and I've done that to tell Python to do the division first and then the exponentiation. So when I run this, you can see I do get at least a decimal approximation of the cube root of 2 as we expect. Okay, so exponentiation is always done with 2 asterisks. Okay, so let's return to doing division. I want to talk about integer division or division with remainder. What I mean by that is you can divide an integer by another integer and get a quotient and a remainder. For example, 7 is equal to 2 times 3 plus 1. So we call 2 the quotient when you divide 7 by 3 and 1 the remainder when you divide 7 by 3. I've written the formal definition in this notebook here. So how can we work out those quotients and remainders in Python? The answer is you can do that using 2 forward slashes to get the quotient and the percent symbol to get the remainder. So as I just said, 7 divided by 3 has a quotient of 2 and a remainder of 1. You can work out the quotient with 2 forward slashes like this, and the remainder with a percent symbol like this. So what I've just worked out tells me that when you divide 7 by 3, you get a quotient of 2 and a remainder of 1. Let's do another example. So let's divide 16 by 5. So of course 16 is 3 times 5 plus 1. So I've got a quotient of 3 and a remainder of 1. So to work out the quotient, we use 2 forward slashes, and we get 3. And to work out the remainder, we use 16% 5. Oops, I've got a 4 there. Let's correct that. And the remainder there is 1. So one reason why this is useful to us is that you know that one integer is exactly divisible by another if and only if the remainder is 0. So if we want to check whether a particular integer is divisible by another integer, we can just check instead whether the remainder is 0. So let's change this 5 to a 4 like I had it before. This time the answer will be 0 because 16 is exactly divisible by 4. So that is a useful trick which we'll return to later. Okay, let's move on to some stupid internet memes which you've all seen. And the reason that these stupid memes where somebody writes down some very ambiguous arithmetic expression are so stupid is because what you should be doing if you've got a complicated expression like this is to use brackets to make the meaning clear, to make the order in which you want the operations to be performed clear. And the same applies to Python. If you have a complicated Python expression, you should use brackets to make clear exactly what you intend that expression to mean. So Python has a lot of internal rules which allows it to make sense of even very complicated expressions like this one. So complicated and potentially ambiguous expressions. It's not going to give you an error when you do this. It will work out an answer. So in particular, Python believes that the correct result of that first stupid meme is 8.5, 8.5. But instead of learning what those complicated internal rules Python uses, what you should do instead is just use brackets to make it clear what you mean. So let me give an example of that. Let's say we want to know how many years there are in 1,000,000,000 seconds. So 1 times 10 to the 9 seconds. Well, to work that out, what you need to do is divide by 60 to get how many minutes, then divide by 60 again, and then divide by 24 to get how many days, and finally to work out how many years to divide by 365. And you can do it like this, just by typing 1 and then 9 zeros, and then divided by 60, divided by 60, divided by 24, divided by 365. It'll give you the correct result, but it's a bad idea because it's ambiguous. It's unclear what that means. Instead, what you should do is use brackets to help make it clear what you actually intend the expression to mean. So this is the same calculation, or at least it would be if I had the right number of zeros. It's the same calculation now, but it's much clearer what's going on because I've used brackets to make it clear what's happening. So I get the same answer, but future me will actually be able to see when I return to this notebook what I meant by that calculation. So that's an illustration of the general principle that you should make Python code that you write easy to understand, not just for Python itself, but for other programmers, including future you. So always think when you're writing Python code, not just does it work, but is it easy to understand? And using brackets to make arithmetic expressions unambiguous is part of making your code easy to understand. Okay, let's put all the things we learned together and solve a quadratic equation using the quadratic formula. So here we have the quadratic formula for the roots of a quadratic equation. We're going to solve a specific quadratic, which is 2x squared plus 5x plus 2. We'll find the roots of this. And of course, the formula is that we need to evaluate minus b plus or minus the square root of b squared minus 4ac, all divided by 2a, where a is the coefficient of x squared, and b is the coefficient of x, and c is the constant term. So let's say we want to do this in this code cell that I've got right here. How do I work it out? Well, I need to start off with minus the linear term, so minus 5. Okay, that's easy enough. We can just type minus 5. And then I need plus or minus. So let's just do the plus root here. So again, we'll just put a plus. And then the next thing I want to do is the square root of something. So we know that to do square roots in Python, we raise the thing whose square root we want to the power 0.5. So I'll put some brackets in, and I'm going to put my b squared minus 4ac inside those brackets. And then I want the square root, so I'll raise it all to the power 0.5. So what do I want in those brackets? Well, I want b squared, which is 5 squared, which we type like this, 5 to the power 2, minus 4ac. So 4 times the coefficient of x squared, which is 2, times the constant term, which is 2. Okay, so what we've got there is the complete numerator in the fraction, which gives us the root of this quadratic. But I need to divide the whole lot by something. So I need some brackets to tell Python that I'm dividing the whole of this line by something else. So let's put the whole thing in brackets, like this. Then I need to divide by 2 times the coefficient of x squared. So if I just do 2 times 2, well, maybe that will work, and maybe that won't. In fact, it won't. You need to put some brackets here to make it completely clear to Python that you're dividing by 2 times 2. Okay, so I've got my expression. Now let's evaluate it by pressing Shift and Enter or Control and Enter. And the answer I seem to get is minus 0.5. Okay, well, did that work or didn't it? It's not really obvious whether it worked or not. So to check whether it worked or not, let's substitute it back into the quadratic and see if we get the answer 0. So I need to substitute minus 0.5 into that expression. So if I do 2 times minus 0.5 squared, again, this is a bad idea. It's ambiguous because it's not clear whether I want to take 0.5 squared and then minus that, or take minus 0.5 and then raise that to the power 2. So again, you should use brackets to make it clear to Python that you want to take minus 0.5 and then raise it to the power 2. Okay, what's next? Plus 5 times minus 0.5. So no ambiguity there, plus 2. All right, so we're done. Let's now evaluate this and see if we get 0. We do, so it looks like our calculation was successful.